Hi friends, I am Sachin Malhotra. Today I am going to be solving problem 1 for homework 4 for EL6303. In the problem we are given y is equal to gx, and the explanation is it is 2 for x less than 0. It is 0 for x between 0 and 1. It is x minus x plus 1 between 1 and 2, and it is minus 1 for x greater than 2. So we have to find the probability density function of the probability distribution function of y and the probability density function of y. So let's solve it. So from gx we can clearly see that fy, the probability distribution function for y less than 1 is equal to 0 and y greater than 2 is equal to 1. Now let's solve between y minus 1 to 2. That is this range. So at y equal to 2, we know that from the formula p of y equal to 2 is equal to p of x equal to 0. At y equal to 2, we know x is equal to 0. So it equals to fx of 0. At y equal to 0, p of y is 0 and x lies between 0 and 1. So p of x between 0 and 1. So it comes out to be fx of 1 minus fx of 0. Similarly, for y equal to minus 1, it comes out to be 1 minus fx of 2. Now for y is equal to minus x plus 1, that is this line, we know that fy of y can be found out by the formula fx upon g dash x taken modulus of that. So x equals to 1 minus y, so this becomes fx of 1 minus y upon minus 1, and taking modulus of that becomes 1. So fy of y becomes fx of 1 minus y. So just stating fy of y, it becomes 1 minus fx of 2 into delta times y plus 1 at y equal to minus 1, fx, small fx into 1 minus y for y between minus 1 to 0, fx of 1 minus fx of 0 into delta y for y equal to 0, and fx of 0 into delta y minus 2 for y equal to 2. Now finding the probability distribution function of y, we know that fy of y is p of y less than y. For y between minus 1 and 0, we can state that fy of y is equal to p of y less than y is equal to p of 1 minus x less than y, where we found this equation from the given gx. Then just solving it out, we get p of x greater than 1 minus y, that is 1 minus p of x less than 1 minus y. So this becomes 1 minus fx of 1 minus y. So just giving you the whole description of capital Fy of y, it is 0 for y less than 1, we already found out. For y between minus 1 and 0, it is 1 minus fx of 1 minus y. For y between 0 and 2, similarly finding out similarly like this, it is 1 minus fx of 0, and it is 1 for y greater than 2. So this is the plot of the probability density function of x that was already given in the question. The probability distribution function of capital Fx. Now plotting this, we can clearly see from Fy that Fy of y is at minus 1, it is 1 minus fx of 2. And from minus 1 to 0, it is small fx of 1 minus y, that is this curve. That at 0, it is another impulse whose area is fx of 1 minus fx of 0. At 2, there is another impulse whose value is fx of 0. From this, we can find capital Fy of y. At minus 1, we have the same values, just this is a continuous curve with some discontinuities. Like it is for minus 1, it is 1 minus fx of 2. Then from minus 1 to 0, it is 1 minus fx, capital Fx of 1 minus y. Then this value is 1 minus fx of 1 at 0. It rises to 1 minus fx of 0, and ultimately it reaches 1.